A very good afternoon to everyone. I, Kriti Vadehra, would like to welcome all the teachers, learners, educators, students to CIT NCERT's live phone-in program. You are watching us live on VmVideocon Channel number 10. This session will be mathematics session for standard 10 students, and the topic which we are going to discuss today is going to be surface areas and volumes. This is going to be the follow-up part of this session. We have already done the introductory part of the chapter, and the expert who has joined us for today's discussion, I would like to introduce Shri Vikram Singh ji. He is principal in Arya Bandhu Public School placed in Ghaziabad. We welcome you, Shri Vikram ji, to VmVidya.
Okay, good afternoon everybody.
Right, and before we start with today's live interaction program, I would like to remind our viewers here that if you have any question, any queries, do let us know. Dial on our toll-free numbers. Numbers would be 1800 and the other number is 1800 To watch the live streaming of this program, kindly log in to our official YouTube channel NCERT Official, and there also in the live chat box you can send all your questions, queries, suggestions. Certainly we will be taking up all the questions sent by you in the last segment of this session. So we shall begin with today's live interaction program on this chapter, which is surface areas and volumes. Vikramji, I welcome you again. I guess we can proceed with the chapter in the next segment now. We've already had introductory session with you. So what are we students going to learn today?
Thank you, Kriti madam. In the first part we have seen the surface area and volume in very short, in which we have discussed the surface area in detail. As I told you, the content of this in NCERT book, it is divided into three portions: surface area, volume, and the interchange of the solids, conversion of the solids. So in that segment, part 1, we have discussed about the surface area in detail. Before going to the next session, first, on behalf of NCERT and myself, I welcome all the viewers and the learners. Now, as far as the introduction of topic is concerned, in this topic, as the words are given, surface area and the volume, mainly we are having these two topics for the solids. And what are the solids? Solids are mainly for the student of 10th class. They are cube and cuboids, cone, cylinder, and the sphere. So we are directly considering these solids in this session. In the first part, we have discussed the surface area in detail, for which we have seen many formula for each solid, like cuboid. So today we are very concerned with the volume part, because we have discussed the surface area in the first part, means in the previous session. Now, as far as this volume is concerned, so I would like to make a type of light on it, the word volume. Volume, actually, in short or in the reference of today, we can say it is volume of the solid. It is equals to the area of the base multiplied by its height. Area of base means, if we are considering the cube, it will be the square. If we are considering the cuboid, it will be in the form of the rectangle. So obviously the area of the base will be L into B. If we multiply it by H, it will be LBH. So the directly volume of the cuboid will be L, B and H. It means the multiplication of all the three dimensions. Now this formula is followed by its diagonal, which is being shown in the slide as square root of the amount of summation of the squares of all the three, L, B and H, where L, B and H are length, breadth and height respectively. The next solid we would like to have as cube. Only the difference in the sides, when all the sides are equal, it becomes the cube. It means cube is a special kind of the cuboid. which has three square faces. If we are considering each side of a cube as small a, it will be the volume will be a cube. The same is area of the base multiplied by its size, as all the sides are equal a and a. So automatically it will be a multiplied by a, the area of the base, which is being multiplied by third is, this is again a, so it becomes a cube. Similarly, the cube has its diagonal in the form of a root 3. Now next solid, this will be cylinder. In the special kind of cylinder, it is right circular cylinder. A cylinder is a solid or a hollow object that has a circular base and a circular top of the same size. So a right circular cylinder, its volume will be area of the base into height. Obviously it will be pi r square multiplied by h, because we are having the base as the circle. So everybody knows the area of the circle is pi r square, where r is the radius of the circle and h is the height of the cylinder. So the volume becomes pi r square h. Now next part is the special part of cylinder, that is hollow cylinder. Hollow cylinder's volume will be, after considering the external radius as capital R and internal radius as small r, so it becomes, volume becomes pi r square h minus pi r square h, where capital R and small r both are different. Now next solid we are having today, that is a sphere. A sphere is a perfectly round geometrical object in three-dimensional space. Examples are the ball, cricket ball, volleyball, or the any type of ball. So its volume will be 4 by 3 pi r cube, where r is the radius of the sphere. Now a spherical cell. Spherical cell, again the small r and the capital R, these are the two r's representing internal radius as well as external radius. So the volume becomes 4 by 3 pi, in bracket we are having r cube minus r cube. Both the r we are taking the differently as internal and external radii. Next part for the solids, a hemisphere. Hemisphere is the half of the sphere. Automatically its volume will be 2 by 3 pi r cube, where r is the radius of the sphere. Similarly, right circular cone. Right circular cone has a circular base and its axis is perpendicular to the base at the center point. If we are taking the small r as the radius and small h is the height, so the volume becomes 1 by 3 pi r square h. As I told you, this small r is the radius of the base, which is circle. Small h is the height. Now before going on its application part, I am interested to give a type of formula, how to learn it, and the same was for area of the trapezium. This is very short video of 10 or 12 seconds. Let us see. As you know, the area of the trapezium is the sum of the parallel side multiplied by height and divided by 2. Let us see it once again how it happened. Similarly, we are having another concept, the same concept, which is sum of the exterior angle of any polygon. Now, we are coming to the application part of these formula we have discussed just now. Actually, in the NCERT book, we are having three exercises, as everybody knows. First exercise is directly related to the surface area, and the second exercise, point 2, is related to the volume portion, and the third exercise related to the conversion of the solids. It means we are converting to another. So in the first session, we have taken the first exercise in detail. Although we have discussed few questions of second, but now we are going to discuss more questions of second exercise, which is the topic of today, the volume. So we are concerned about the volume especially. So I am going to take the questions of second exercise. They are directly related to the volume. Now this question is question number 3 of the exercise. As I told earlier, before attempting the question, it is very
Right.
necessary.
Vikramji, we can't get the full screen of yours. I would request you to kindly make the full screen of your presentation so that it is, visible for all our viewers properly.
Okay, ma'am.
Yeah.
Actually, ma'am, there is a disturbance from your side of something noise is happening there. Am I right?
No, it is all silent in the studio, I guess.
Okay.
But it
Okay,
must be
madam.
on your side.
Okay, madam. Okay. Now, as far as this question is concerned, this question number 3 of the exercise point 2, I am reading for the learners. I hope that they are not having the textbook. If they are having, that's good. But those who are not having the textbook just now, so let us see what is the question. A gulab jamun, a type of sweet dish, contains sugar syrup up to about 30% of its volume. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like a cylinder with 2 hemispherical ends, with length 5 cm and the diameter 2.8 cm. For the simplicity of the learner, the figure is given in the question itself. So, just I am going to make this question more clear. A gulab jamun means this is the combination of, it is given in the question, the combination of cylinder and 2 hemisphericals on both the ends. It means we are very concerned with 2 types of solids in this question, cylinder as well as the hemispheres. The dimensions are given and the quantity of the gulab jamun is also given, and the volume of the syrup is also given in its percentage. So we have to find the approximate syrup of the in the volume form. Now let us see its solution. So this is the figure. In figure, as we have discussed, in between, that is the cylinder, and in both the ends, these are the hemispheres, that one, and in the right side this one. The Total height of the rasgulla is given, the gulab jamun is 5 centimeter, and the radius of this part is 1.4. This 1.4 is coming from the half of this diameter. Diameter was 2.8. So after taking its half, it is 1.4. 1.4, the same will be as 1.4, and this part also will be the same length, 1.4 centimeter. This is 1.4. Again in this side, this is 1.4. So the height of the cylindrical portion will be 5 minus 1.4 plus 1.4. It means it will be 2.2. So it is indicating by the arrow 2.2. This 2.2 is the height of the cylindrical portion, and the radius of the cylinder will be automatically as 1.4. So this is not given in this PPT, but I made all the things clear. Again, I am taking the same description. For cylindrical portion, height of the cylinder is 2.2, radius is 1.4. Similarly, the radius of the hemisphere is 1.4. Now, it is very clear that the volume of a gulab jamun will be volume of cylinder plus volume of two hemispheres. So let us see the formula for the same as we have discussed earlier. This is 2 by 3 pi r cube, the volume of the first hemisphere. This is pi r square, volume of the cylinder, and the same 2 by 3 plus 2 by 3 multiplied by pi r cube, it is for the second semicircle. So put all the values, we are getting 2 by 3, r is 1.4, its cube, again pi multiplied by 1.4 its whole square multiplied by the height of the cylinder, that is 2.2, 2 by 3 multiplied by pi and 1.4 its whole cube. After simplification, or we are taking this common pi as 1.4 its whole square, we are having inside of the bracket 4 multiplied 1.4 divided by 3 plus 2.2, and multiplication of both the quantity will be 5.6 plus 6.6 divided by 3 after taking the LCM 2. We are having this quantity 1.96 multiplied by 12.2 divided by 3 pi centimeter cube. Actually, this is the volume of a solid or a gulab jamun, you can say. What in the problem we are having 45 gulab jamuns, so we have to need, or we have to calculate the volume of 45 such gulab jamuns. So what will be the amount? The amount will be multiplied by 45. It is the volume of a gulab jamun, so it becomes 1127.28 centimeter cube. According to the question, the volume of the syrup is 30% of the volume of the 45 gulab jamuns. So just take its 30%, 1127.28 multiplied by 30 upon 100, it becomes 338 centimeter cube approximately. So our answer will be 338 centimeter cube, which was asked in the question. In the question, it is demanded that find the approximately how much syrup would be found. So our answer will be 338 centimeter cube. So for this question, especially for the solution of this question, just I am going to summarize the solution, then we will proceed. Actually, in the question, the solid is in the form of the combination of two cylinder as well as hemisphere. So we have to need its volume in the form of volume of the cylinder and the volume of both the hemispheres. So separately we have calculated the volume of the cylinder and volume of both the hemispheres. Then we have taken its sum, and automatically this sum will be the volume of a gulab jamun. In the question we are having 45 such gulab jamun, so we have to take its volume after taking multiplied by 45. So this will be the total volume. But as far as the volume of syrup is concerned, so we have to take its 30%. So the 30% will be 338. So this is all about the question in short. Now the second question of this exercise, which is numbered as 4 in the exercise itself. If you want to see the textbook, automatically it is in the textbook. This is textbook chapter 13, as I told you. So just see one by one the exercise. Point 1, we are not concerned with that. We have discussed this exercise in the previous session.
Right.
Now,
Vikramji, here I would like to request you again, please make the full screen of your presentation so that it is visible properly to our viewers.
Actually, the same is given in the PPT, madam. Just I am giving the hint. This is the type of that one. If you want to see in full, that is that one.
Okay.
The same question number 3 we have discussed just now. We are going to discuss the more question of the same exercise. Now this is the question, next question of the exercise, question number 4. So let us see in its full screen form. We have discussed that one. Now for the same learners, we are going to read this question. Question number 4, a pen stand. Actually, this is the pen stand usually found on the tables of the officers or a student. This is the pen stand, and we are discussing about it. A pen stand made of wood is in the shape of cuboid with 4 conical depressions to ends. Dimensions of the cube are 15 centimeter by 10 centimeter by 3.5 centimeter. The radius of each of the depressions is 0.5 centimeter and the depth is 1.4 centimeter. Find the volume of the wood in the entire stand. For the simplicity, figure is also given. Now again I am going to make this question clear in the mathematics contest. The cuboid, all the 3 dimensions of the cuboid are given as 15, 10 and 3.5, and the radius of the depression, obviously these depressions are in the form of circle at the top. The radius of the depression is 0.5 centimeter and the depth is 1.4 centimeter. If see it mathematically, it will be a cone in some sense, the depression. How many depressions are there? There are 4 depressions. So we have to calculate once, then we will take its multiplication in 4. So we are having the 4 depressions. Now let us see its solution. Solution will be of this type. First we are discussing with the cuboid, then we will come to the cone, because in this question we are concerning with 2 solids, cone as well as cuboid. So as I told you, length is 15, breadth is 10 and height is 3.5 centimeter respectively. So LBH nominations are like that. Now according to the formula, we are having the volume of the cuboid will be LBH. So after putting all the values, we are having 15 multiplied by 10 multiplied by 3.5. So after calculating this, it becomes 5 to 5 centimeter cube. It means the volume of the cuboid portion is 5 to 5 centimeter cube. Now for conical portion, as it is given in the question, the radius is 0.5 centimeter and height is 1.4 centimeter. As we know, the volume of the cone is 1 by 3 pi r square h. So applying the same formula, we are having the radius and the height above. Radius is 0.5 and height is 1.4 centimeter. Putting both the values in the expression, we are having 1 by 3 multiplied by 22 upon 7, which is the value of pi, multiplied by 0.5, 0.5 again because this is r square, multiplied by 1.4. So after calculation done, it is 11 upon 30 centimeter cube. Now this is the volume of a cone, means this is the volume of a depression. Now we are having four conical depressions, so the volume of all the conical depressions will be 4 multiplied by 1.47. After calculating this amount, 4 centimeter cube. This is the volume of all four depressions. It is very usual to find the volume of the wood in entire stand. It will be volume of the keyword minus volume of all four depressions. So 5 to 5 minus 1.47. So it becomes 5 to 3.53 centimeter cube. Again, I am repeating the amount 5 to 3.53. It is all about the question which was asked. This was asked that find the volume of the wood in entire stand. So it comes the 5 to 5.53 unit cube. Now I am going to summarize the same to make it more clear. For the keyboard portion, L is 15, B is 10, H is 3.5. So the volume of the keyboard will be the multiplication of all the three quantities LBH 15, 10 and 3.5. It becomes 5 centimeter cube. For cone, radius is 0.5 centimeter and height is 1.4 centimeter. So the volume of a depression which is in the form of cone, it becomes 1 by 3 pi r square h. After putting all the values, we are having the volume of a depression 11 upon 30 centimeter cube. So after taking multiplied by 4, because we are having 4 such depressions, it becomes 1.47 centimeter cube. So the volume of wood in the entire stand will be the subtraction of 4 depressions from the volume of the keyboard. So it will be 5 to 5 minus 1.47, which becomes 5 to 3.53 centimeter cube. This is all about the solution of this question, which is numbered 4. Now again we are having many questions in the exercise of same type, but we are taking the questions of typical type of questions, which was numbered 3 and number 4. Sorry. The same, this question number 6. A solid iron pole consists of a cylinder of height 22 centimeter and base diameter 24 centimeter, which is surmounted by another cylinder of height 60 centimeter and radius 8 centimeter. Find the mass of the pole. Actually, we have discussed this question number 6 in our previous session, so I need not to discuss this question again because time saving is compulsory. So I am not going to discuss with question number 6 because I have discussed this question number 6 in previous session in detail. So we are going to proceed for the next questions. This is question number 7 and 8 likewise. So the next question will be question number 7. Don't worry about it, or don't think that you are quoting question number 6, because we have discussed question number 6 in our previous session. So now question number 7. Again, I am reading for the learners the question number 7.
Right. It will be good if you make the full screen of your presentation, Vikramji.
Yes, yes, ma'am, I am.
Right. Many viewers are watching us live on YouTube. It will be easy for them to understand.
Okay, okay, ma'am, okay, I understand. This is question number 7. 7 question says, a solid consisting a right circular cone of height 120 centimeter and radius 60 centimeter is standing on a hemisphere of radius 60 centimeter. Actually, you are seeing this is the question coming from very easy to tough type questions. So you can say this is the question of HOTS type. HOTS means higher order thinking skill. A solid consisting of a right circular cone of height 120 centimeter and the radius 60 centimeter is standing on a hemisphere of radius 60 centimeter is placed upright in a right circular cylinder full of water such that it touches the bottom. Find the volume of water left in the cylinder if the radius of the cylinder is 60 centimeter and its height is 180 centimeter. So before going to its solution, just I want to suggest the learners or the viewers, don't get confused about these quantities, because in this question number 60 is coming frequently, and there are 2 or 3 solids consisting in this question, or this question having 2 or 3 solids. So make it clear which type of solid and which type of the outer solid is given. So for that you can read this question again to make the question clear and all the things clear. 60, 60, 60 and 120, and which one is the height and which one is the total height, which is the radius and which is the radius for the particular portion. So just read it once at your own end. Just I am going to read it or I am going to make it clear in quick form. That is, the height is 120, radius 60, and the hemisphere radius 60 centimeter, and there another cylinder, and it will full water, and if the radius of the cylinder is 60 centimeter and its height is 120 centimeter. Now what is to find? After putting the object inside, you have to find the volume of the water left with the cylinder. So this is the question which we are going to calculate, the amount of the water remaining. Now let us see its solution. As I told, we are going to see one by one the solids. The first one is for the cone. The radius of the base is 60 centimeter, height is 120 centimeter. So the volume becomes 1 by 3 pi r square h. On putting the values of r and h, it becomes 1 by 3 pi as well. 60 its whole square multiplied by 20. So it becomes 144,000 pi centimeter cube. Similarly, for the hemisphere portion, radius of the base is 60. Its volume will be 2 by 3 pi r cube. Again 2 by 3 pi is the same and r is 60. So it becomes again 144,000 pi centimeter cube. For right circular portion, right circular cylinder, radius of the base is 60, height is 180, and the volume will be pi r square h, pi 60 square plus 180. So it is 648,000 pi centimeter cube. So we have calculated all the 3 volumes, and we are going to use these volumes according to the requirement of the question. So the volume of the water left in the cylinder, automatically it will be, first we will take the addition of the 2 volumes, the volume of the hemisphere and the volume of the cone. Then we will take its subtraction from the volume of the cylinder. So automatically the volume of the water left in the cylinder will be the volume of the cylinder minus summation of both the volumes of cone as well as hemisphere. So it becomes 644,000 pi minus 144,000 pi plus 144,000 pi. So after calculating, it becomes 360 triple pi centimeter cube. So actually this is all about the solution of this question. Just I am going to summarize. In the starting, we are going to calculate all the three volumes: volume of the cone, volume of the hemisphere, and volume of the cylinder. After putting all the values respectively, so we are having addition of two volumes, volume of the hemisphere and the volume of the cone, and we are taking the subtraction of these volumes from the volume of the cylinder. So automatically we are having the required volume, because it was asked in the question that find the volume of the water left in the cylinder. You have to calculate the amount of that water which is with the cylinder after that. So it is 360,000 pi centimeter cube. I hope that this is the all about the question. Now one more question of the same exercise we are discussing. Question number 8 of the same exercise. Again I am suggesting to read this question thoroughly. A spherical glass vessel has a cylindrical neck which is 8 centimeter long and 2 centimeter in the diameter. The diameter of the spherical part is 8.5 centimeter. It means we have to very precise and we are very attentive while reading the question. A spherical glass vessel has a cylindrical neck 8 centimeter long, 2 centimeter in diameter. The diameter of the spherical part is 8.5 centimeter. By measuring the amount of the water it holds, a child finds its volume to be 345 centimeter cube. Check whether C is correct, taking the above as the inside measurements and the value of pi is 3.14. Now although volume is calculated in the question, but we have to check the correctness of this volume. Is this correct or not? So before going for the solution, just I am going to read it in short. The radius is given and the height is given, and again the diameter of the spherical part is given, and the volume of this solid is also given. But we are going to check this amount of the volume, is it correct or not, which was calculated by a student. After or being calculated, the value of pi is used as 3.14. As you know, the value of pi is very large after the decimal, as I told you in the previous session. For the simplicity or for the learning, we are having or we are using such type of tricks as most of the teachers are doing in the classes. The value of pi will be, may I have a large container of coffee. May I have a large container of coffee. Just write down all the letters of the word respectively and put the decimal after 3. Automatically you are having the value of pi, which is 3.14 and so on. But in this particular question we are having the value of pi up to 2 places of the decimal. Now see its solution now. The diameter of the cylinder is 2 centimeter and height is 8 centimeter. And for the sphere, the diameter of the sphere is 8.5 centimeter. So the amount of the water it holds, it means the amount of water will equals to the volume of the solid, or the solid is consisting two type of special type of solids. This is a sphere and the cylinder. So we are going to calculate the volume of both the solids or its part separately. The volume of the sphere will be 4 by 3 pi r cube and the volume of the cylinder will be pi r square h. On putting the values of these variables respectively, we are having such type of condition or the situation. This is 4 by 3 pi, 8.5 upon 2 its whole cube. This is the radius after dividing by 2 the diameter. If we are going to find the radius, we have to divide it by 2, because everybody knows diameter is the half of, radius is the half of the diameter. Similarly, here pi 2 by 2, because 2 is the diameter, so radius will be 2 by 2. Its whole square multiplied by 8. So after calculating, it becomes 4 by 3 multiplied by the value of pi 3.14, which is mentioned in the question, 4.25, again 4.25, 4.25 and 8, 3.14. So all about the calculation goes to this condition. This becomes 3 to 1.39 plus 2 5.12. So in short, or at the last stage, it becomes 346.51 centimeter cube. It means after calculation using such dimensions which are given in the question, our amount of the volume becomes 346.51, but the student calculated this volume as the different one, which was given in the question as 345 accurately, but our amount of the same volume is 346.51. In that sense, these two quantities are different. So the volume which is given in the question or calculated by the girl is not correct. So our answer will be, hence C is not correct. The correct volume is 346.51. So this was about the solution of that question, which was calculated by the girl as 345, but our volume after calculation comes as 346.51. In that sense, this was not the correct one. So we will say this is not the correct amount. Now this is all about the exercise questions. As I told you, questions of the NCERT book. But if we want to discuss one or two questions more, we can discuss like that. Then we are going to use the NCERT exemplars. Actually 6 we have discussed in first part, 7 we have just now, and this 8 also. It means this exercise is completed in all the sense. It means we have discussed all the questions of this point 2 exercise, including the questions of previous session. It means this exercise is over now from my part. If any learner has the question, just collect all the questions so that we can discuss at the end of the session today itself. Now, before going to the exemplar questions, just I want to tell you something about the conversion of the solids from one shape to another. It will be better to discuss it after the exercise over for this exemplar. So just come to that one, NCERT exemplar. I have taken 1 and 2 questions from that one, although we have discussed all the questions of NCERT book, but there are few questions. I want to make one thing clear. There is no difference between the questions of NCERT book and exemplary. Both are same, and both are authors are same NCERT, and the pattern of the question is same, label of the question is same, but the quantity of the question is different. In some questions the quantity is given of that type, and in some questions the quantity of given this type. So don't worry about, go for that, the NCERT exemplars. So see 1 or 2 questions for that. This is question number 10 of that. Question number 10 says marbles of diameter. You know marble. Most of the students have played with this in the childhood. The marbles. Some people call it kancha, goli.
Ji.
Yes, yes.
It'll be better to visualize and see if the screen is in full screen mode, your presentation, Vikram ji.
Okay, I have done better.
Yeah.
So just go for the question. Marbles of the diameter 1.4 centimeter. It means automatically marbles are in the shape of the sphere. So the diameter of that sphere is given as 1.4 centimeter. So again I am reading the question for the simplicity. Marbles of the diameter 1.4 centimeter are dropped into a cylindrical beaker. Beaker is a type of instrument which we are using in the labs. Beaker of diameter 7 centimeter containing some water. It means beaker containing some water which is not fully filled with the water. Find the number of the marbles that should be dropped into the beaker so that water level rises by 5.6 centimeter. It means for the simplicity of the question, or we are going to make this question simple, we are having a beaker. In this beaker we are having a water up to a certain height. We are dropping few marbles in that water. Automatically water rises. So the height of the water rises after dropping these marbles. It is 5.6 centimeter. So we have to calculate the number of the marbles. It means how many marbles have been dropped in the beaker to raise the water height by 5.6 centimeter. First let us see its figure. Figure is also given. This is the beaker, this one, and in the starting this was the level of the water before dropping the marbles. After dropping the marbles, the water reaches up to this stage. It means this is the height raised after dropping the marbles. So we have to calculate it. The volume of the water raised by this cause. Automatically this volume will be the volume of the all marbles. So we will see after that how much marbles are there. So in the starting it is said the number of marbles, we are taking the small n. Small n is our assumption to take the number of marbles. So when n marbles are dropped into the beaker filled partially with the water, the volume of water raised in the beaker will be equal to the volume of n marbles. As I told you, the same. The shape of the water raised in the beaker is cylindrical. It means the radius of the cylinder is 3.5, and for spherical portion the radius is half of the diameter, this is 0.7. Height raised, it is 5.6 which is given in the question undoubtedly. So the volume of n spherical balls or the marbles will be the volume of the water raised in the cylinder. So this will be equals to n multiplied by the volume of a marble. And I told in the starting of the question this marble is the sphere. So automatically the volume, formula of the volume we are using for the sphere, that is 4 by 3 pi r cube. The capital R is the radius of that marble equals to pi r square. The small r is the radius of the cylinder. So after putting all the values 4 by 3, 0.7, 0.7, 0.7, this is equals to 3.5, 3.5 and 5.6. After taking this quantity another side, it means the known quantity and unknown separately, this n becomes this type of quantity 3, 35, 35, 5, 6 multiplied by 3, 4777. So after calculating, it becomes 150. It means the value of n is 150. Hence the required number of the marble is 150. It means we have dropped 150 marbles in that beaker. Now I am going to make it more clear and short. We have calculated the volume of this water. This water will be equals to the volume of all the marbles. So we have taken its volume equal. After taking its volume equal, we are having this volume, and after taking its division, we are having the number of the marbles. So which comes 150. It means 150 is the number of the marbles dropped in the beaker. So this was asked in the question, find the number of the marbles that should be dropped in the beaker so that water level rises by 5.6 centimeter. So this is our answer, 150. Now as I told you, this is all about the question, but let us see something for the correctness of this NCERT. We are having third exercise is conversion of the solids from one shape to another. Actually, this exercise is also related with the volume portion. So we have to calculate the volume after conversion and before conversion. Before conversion, volume will equal to the conversion volume after conversion. We are going to take this assumption for the next coming exercise, and which will be followed by the expert in the next session. So it is all about the today's topic, surface area and volume. From my side, today we have discussed all about the volume especially, and before going to the question part, just I am going to summarize the today's topic or the today's discussion. I have discussed mainly about the volume of the solids which are concerned with the sphere, cone, cylinder, which we are having the question. Just I suggest the learners of the student just to go for the more questions for the practice. If you are having any type of problem, just discuss, don't avoid it. So before leaving for the question part, just I want to give my hearty thanks to NCERT, especially CIET, to give me the chance again delivering my class according to my knowledge and based on my knowledge. Thank you very much, and it's over to you, Kriti madam, for the questions and the discussions.
Okay. Many viewers are continuously watching us live. Viewers, I would like to request you, if you have any questions regarding the presentation which Vikramji just shared, you can send your queries on the live streaming which is happening now. We will be taking up all your questions. Vikramji, any tips to solve these problems which you have discussed? Both the sessions you've taken, and any tips to be shared with students to be kept in mind while doing the solutions for this chapter? Vikramji, can you hear me? Am I audible to you, Vikramji? I guess there's a technical glitch. Vikramji, can you hear me? Am I audible to you? Okay, so Vikram Singh ji was there with us. He explained so well about the chapter surface areas and volumes, and it was the follow-up session, the second part of this chapter, in which Vikram ji explained it so well. I mean, he took the problems which are given in the NCERT books and he shown it in his presentation. He has explained it very well to our 10th standard students that how you have to attempt these questions, how to go further in this chapter. He will be discussing in more details about the volumes, as he said, in the upcoming sessions. And this was session for standard 10th mathematics students. Keep watching NCERT's resource material on PM eVidya. Thank you. Namaskar.